Hello, everybody, and welcome to the Reuse Company webinars. You will be muted during the webinar, but if you have any comments, you can use the chat, and if you have any questions for the presenter, you can use the question section. Jose will answer your questions at the end of the webinar. The webinar will be recorded, and in a few days, we will send you the link to the recording. Today's topic is the systems requirements made easy with ears patterns and the RAT authoring tool. And today's presenter is Jose Fuentes. My name is Cecilia Carlson, and I will be hosting the webinar. This is the agenda for today. First, we will have a short introduction to the company and the presenter. Then we will see what ears is. Next, we have writing system requirements with RAT based on ears patterns. And after that, we will see a demonstration. And finally, we will have some time for Q&A. So first, a few words about the Reuse Company. Here you can see a little bit of our history, but we will jump directly to the next slide. What do we do at the Reuse Company? Well, our company is a tool vendor specialized in the application of semantic technologies and artificial intelligence to improve the digitalization of the systems engineering life cycle. Here is an overview of our tools. We are usually known in the market for our tools for requirements engineering, our QA quality studio to check the quality of our requirements, and RAT authoring tool, our writing assistant. Nowadays, you can also use them to improve the quality of other texts as well as models. Then we have Traceability Studio, B&V Studio, and KM Knowledge Manager. And now we're launching our newest product, SES Engineering Studio. SES Engineering Studio offers full support for technical management processes as in ISO 15288, quality, traces, document management system, and V&V. And we have the interoperability hub, offers connectivity between the different tools in our ecosystem and makes them interoperate. And with our add-in Rex, you can use MS Word as a requirements engineering tool. SES Engineering Studio also offers system lifecycle management, including knowledge and information management, requirements reuse, virtual assistants, search engines, ontologies, PLE, etc. This is an overview of which sectors are using our technology. So let's go to the next slide. Our presenter today is Jose Fuentes. He is the Chief Sales Manager at the Reuse Company, and he's the former product manager of our QA Quality Studio and the Systems Engineering Suite. He has the INCOSA CSEP certification and has graduated from the INCOSA Institute for Technical Leadership. Jose is an active contributor to the INCOSA Guide to Writing Requirements. He is certified in ITIL and is interested in project management, business analysis, and risk management. So let's start with today's topic. Hello, Jose.
Hello, Cecilia. Can you hear me well?
Yes.
Okay, thank you. So today's topic, nice topic, ears. So what is ears, by the way? Ears is just a catalog of different patterns patterns, boilerplates, or statement level templates to write well-formed requirements. So a pattern normally is formed up by a sequence of different what we call pattern slots, meaning the different blocks conforming this full pattern or the structure of a full requirement. It includes some, let's say, common and meaningless little words like prepositions, determiners, and so on and so forth. But the most important point, especially when it comes to connecting these patterns to dictionary, are the other elements that can be mapped with architectural elements or design elements like name of components, functions, interfaces, states, actors, and this kind of meaningful information, right? So those following these patterns, it could be years patterns or other different catalogs of patterns, allows us or provide us the means to reach the level of consistency that we need. First, in terms of the structure. So by following different full set of requirements following the same catalog of patterns will guarantee that the structure will be uniform or consistent, and also consistency in terms of the vocabulary that we use if we manage to connect, as I mentioned, the different pattern slots to domain-specific dictionary. Of course, those patterns can help us during the elicitation, but mainly during the definition, the stage where we write down our requirements. It facilitates requirement reuse. It facilitates the detection of duplicate requirements. If we manage all of our requirements to have to follow the same structure and to follow somehow same set of terms, then we will very easily identify duplicate requirements, and will allows us to extract data from textual requirements, data like actual values for different units or systems or different properties, sorry, and this kind of thing, right? So these are all the benefits of using patterns. And today we will focus on years pattern, right? So what you see here is that years patterns, the full catalog includes 6 different types of patterns. I will review these 6 types of patterns right away. But just as a reminder, we at the Reuse Company, we presented a couple of years ago a webinar with one of the creators of years, Alistair Mavin. And if you follow this link, you will reach to this recording where Maeve was presenting those patterns. So first of the first pattern is ubiquitous requirement. Ubiquitous requirement is a very little, a very small pattern, only with the name of a system element plus the system response. The bad point is that when I see a specification from customers and from colleagues, most of the time we tended to write just this very simple ubiquitous requirement without any additional condition or any additional trigger or whatever, right? So as we will see during the webinar today, it is clear that ubiquitous requirement is one more of the different types of requirements that we can manage. But the point will be that we should tend to avoid or to just use this ubiquitous for very, very, very specific topics, right? Like, for instance, this one, the weight of the temperature warrior, which is the name of my system, shall be less than 5 kilos. I want this constraint or this requirement to be active all over the lifespan of my system. So not after a specific trigger, not when the system is in specific mode, but during the full life cycle of my system, I would like it to weigh less than 5 kilos, right? So this is the notion of ubiquitous. It is always active. However, for the rest of the potential types of requirements, you will see things like, in this case, precondition or context, where this requirement or the requirements following this second pattern are only active while this precondition is true, let's say. So while I am in a given mode, for instance, like in this example, while the temperature warrior is in attack mode, which is a specific mode, then the rest of my requirement, which is a kind of ubiquitous requirement now after this precondition, shall be always active while I am in this attack mode. So the power system shall show the temperature of the battle sensor. This has to be active all the time while I am in this attack mode. Next example are the event-driven requirements, where it is a more, let's say, atomic reaction of the system to a given trigger. This trigger is a discrete event, like when the temperature warrior receives an attack from the enemy, which is in a very specific moment in time, then the temperature warrior shall enter into defense mode. So it is a discrete event, as I said. Then we have optional features. So things that are always truth. For instance, when we have different, let's say, if we follow, for instance, a product line engineering approach, when we have a specific configuration of my system, like, for example, when where the accessibility feature is activated, then the requirement is to be truth only when this is activated, right? In this particular configuration. Right, so the temperature warrior shall read aloud all the messages shown in the main display. Then we have unwanted behavior. To some extent, we can say that unwanted behavior and the event-driven requirements are pretty much alike, right? So both are very similar with a trigger. The trigger, as happened with the event-driven, is a discrete event. If the triggering occurs, then the system shall provide a response. In this case, as we like, informatic people, as we like, after the if, we have the then, so we like it. So then we see this then in this particular pattern, not in the event-driven. And the main difference between the event-driven and the unwanted behavior is that the unwanted behavior is presenting an event, a discrete event, that will only happen to represent something which is not the regular, let's say, the regular scenario that we expect, right? So if we distinguish scenarios between the, let's say, the sunny day scenario, if everything goes as expected, and the rainy day scenario, where something is not going as expected, so this is the rainy day. If the operator enters an attack temperature lower than the ambient temperature, the temperature warrior shall show an error message in the main display. So this is something that is not the expected behavior, and that's why we have used the unwanted behavior and not the event-driven behavior. And then it comes the latest pattern. I have to admit that I don't like this name. So this is the official name in the EARS approach. The official name for this is complex pattern. But in the end, this complex pattern is nothing else than a combination between state-driven plus event-driven or unwanted behavior. So in this example, I have entered just the keyword when. It could be when or it could be if, right? So if you put together first the state precondition while the temperature warrior is in attack mode, and then a discrete event like when the temperature sensor reaches the maximum limit established, and then it comes the action, the temperature warrior shall enter into the idle mode, right? So as I said, this is to me this is the most typical pattern where we mix together both precondition state with the while and trigger with the when or with the if, right? So as you can see, each one of those patterns comes with a particular keyword, except for the ubiquitous. There is no keyword in the ubiquitous, but for the state-driven, we have the while. For the event-driven, we have the when. For the optional, we have the where. For the unwanted, we have the if. And then the complex, we merge while plus when or while plus if, right? So this is the notion of EARS. So typically, EARS has demonstrated an improvement for those companies adopting EARS as the standard to write requirements they have demonstrated that the most common mistakes in requirements are somehow minimized or even fully removed. And of course, for those aspects that are not fully removed, of course, you can rely on additional sets of real-time metrics or rules that can be checked thanks to tools like our authoring tool that will be also the star character for this presentation. So this is coming from the authors of EARS, where they have listed the most challenging topics when it comes to writing requirements, like untestability, implementation, wordiness, duplication, omission, complexity, vagueness, and ambiguity. The dark bar in this chart is representing how important these issues are when not using EARS, and the lighter bar, which in some cases are fully zero or fully removed, represents this problem when you are using EARS approach. So as you can see, aspects like duplication, as I mentioned before, is fully removed. Of course, wordiness, or one of the most typical aspects where your requirements are, I don't know, 1 paragraph, 2 paragraph, 3 paragraph long. Of course, when following this kind of approaches, the wordiness is fully minimized. Omission, because after following this approach with all the keywords, it is more complicated to miss the condition, which is one of the aspects when you are not helped by patterns. The reduction in ambiguity, it's something that, of course, by forcing authors follow a given structure, there are less chances to enter ambiguous content. However, I don't fully agree with the approach of having EARS to fully remove ambiguity. However, as I said, most of the main aspects are fully removed, and all others still remain, as you can see here. And of course, with the help of a tool, we can remove all these aspects. So while using EARS, when the author finds a problem, the authoring tool, the RAT authoring tool that I will present to you today, can be implemented to assist the authors in order to improve efficiency, right? So this is my piece of requirement for today. So, as I mentioned before, if you want to know more about EARS approach, or if you want even to listen to the authors or the main creators of EARS, just follow the link that I presented in my previous slide, and then you have a full webinar by Alistair Maybe. So, second important point when it comes to using patterns is how to connect patterns to a project data dictionary, right? Let me describe this aspect with an example. So this is my requirement. Again, speaking about the same system, while the temperature warrior is in attack mode, when the temperature sensor reaches the maximum temperature established, the temperature warrior shall enter into idle mode. So this is the same example as I used before for the full, the so-called complex pattern that, as I said, I normally don't call it complex pattern. If you go in detail, then you can see the precondition after the while, the trigger after the when, the name of the system, and the system response. So you see the main elements in here. However, if you go in more detail, then, this is the precondition, the trigger, the system, and the system response, right? However, if you go in more detail, then you can identify even the individual building blocks of this requirement, right? Because we can take the while precondition and say that the while precondition in this particular example, there could be other grammars, different grammars for the while precondition, but in this case, it is just the name of a component plus a given mode. So when one particular component is in a given mode. So quickly speaking, you can notice that in this example I have used systems, a couple of them. Well, it is the same system, repeated twice. Name of a component, a couple of different modes, one property, maximum temperature, and one action to enter, let's say, right? So in EOS, EOS ends in just the definition of the main keywords and what comes after the keywords, the precondition, the trigger, the system response, and so on and so forth. However, in our approach with the automatic with the requirements assistant, with the authoring tool, we like to connect these to domain-specific dictionaries. So those dictionaries could be either our native reuse ontologies. So whenever you see this, this strange shape, this is representing our native ontologies in reuse company. Or you can establish the ontology to be connected, as you will see later, to be connected to your preferred modeling tool. Could be Capella, it could be Cameo, Enterprise Architect, Papyrus, or plenty of other model-based systems engineering tools, right? Could be conceptual modeling or even physical modeling. You can learn more about data dictionaries by following this link. So this is a link now to a webinar that was presented by one of my colleagues. I think it was something like 5-6 months ago, right? So data dictionaries where we can find the main elements in our patterns. So if we start with the system name, of course, the system name is depending on if we are speaking about system requirements or stakeholder requirements. It could be the actors for stakeholder requirements, or it could be the name of the systems, the subsystems, and components in a modeling tool, right? If we focus now in a system response, according to EOS, system response is whatever. So system response. You write whatever you want in this system response. However, what we have done in our implementation of EOS is that we have extended this system response to allow more thorough guidance to the authors. That is why we have established up to 8 different possibilities for the system response, like just taking a name of a verb from the ontology, or the name of a function from your modeling tool. So this is one option, just to have a verb or to have the name of a function as the system response, right? Other possibilities could be to provide an entity with the ability to perform an action as established in the first block. So this little pattern is connecting or is linking this previous pattern, or the same, but including, let's say, another entity as an object, right? So a verb plus another entity, or we can even include, let's say, something like a direct object and indirect object, if you wish, in your example. So something like a verb plus what is working with this verb. Let's say something like send a message to a recipient, for example. So this could be an example of this action tree. And then, as you can see, some other possible aspects, including something like setting a given value for a property, or changing a state, transiting, changing from one state to another. So different possibilities to be more precise in this system response. When it comes to the definition of the system response, of course, you can end like this, just with these potential system responses, or you can even add more information like time constraint. Suppose that you want to provide some sort of constraint. That could be time constraint, or could be performance information, accuracy information. So you can provide all these additional information, or you can even refer to a given standard, a given document to say in accordance with a given standard, or as defined in whatever document, page, section, whatever. So this is how we have extended the definition of the let's say basic system response into a more complete aspect for the ubiquitous requirement. So this is still the ubiquitous requirement. If we now go for other types of requirements, like the while state-driven requirements, right? So we have done pretty much the same. We have taken this precondition after the while keyword, And we have come out with different potential ways to represent this precondition, like the name of a system, of course, coming this system from your modeling tool, which is in a given mode, coming, well, this slide, I say, coming from Enterprise Architect, but it could be whatever other modeling tool, or system, which is, I don't know, a verb, system, a verb representing a mode, a state, system, which is, I don't know, activated or not activated, whatever, right? Or an entity, which is detected by another entity, that could be the fourth element, or while a property has a value of whatever. So whenever this property has this value, then this requirement becomes activated, let's say, right? So again, a potential set of different substructures to represent the precondition. This is what we call subpatterns. Similar for the trigger. So we have created these 7 potential ways to represent a discrete trigger. Same for the where feature, the if triggers as well, which are pretty much the same as the when trigger. And this is what we have implemented. Now, how can you reach these ES patterns, and how can you reach this extension of the ES patterns with all these subgrammars? All this is implemented through our RAT tool, the authoring tool, right? So how does this tool connect to the rest of the ecosystem? So this is the full ecosystem, right? Where we have this tool representing the RAT. RAT is connected, of course, as I was mentioning before, connected to our ontology. In this ontology, we have defined patterns. Patterns are defined with a knowledge manager. However, the patterns that, as I have presented in these slides, are already part of one of our libraries. So you can take KM and just import the library, including the EOS patterns. And also, you can use the RQA in case you want to have things like additional metrics, like those defined by INCOSE, for instance. Then you can use RQA to establish a catalog of different metrics. So the metrics that you define in RQA and the patterns that either you import as a library from KM, or you can tailor those patterns from using KM, all this information will be always stored, represented in our ontology. As I was mentioning before, you can ask Knowledge Manager also to connect to one or more modeling tools, so that the content of the data dictionary will come as a merge between the information, native information in our ontology, and the information coming from external models, let's say Capella, Cameo, Enterprise Architect, or some others, right? So with all this information, we will conform the content of the ontology. RAT will connect to the ontology, and the way you reach RAT is, well, there are different ways to reach the RAT tool. One is RAT is included in our tool Engineering Studio. So for those of you using the Engineering Studio, you must know that you all have RAT inside of it. You can also use RAT inside of Microsoft Word. Remember that we have deployed an add-in of the Engineering Studio inside of Microsoft Word. So by doing so, you will have RAT inside of Word. RAT can be also an add-in on top of many different requirements management tools. So in this little example, I have used IBM Doors. So we have an add-in of RAT on top of Doors. We have similar for other tools like PTC Windchill and some others. And including Microsoft Excel as well. And we have also created an extension for web browsers. So that means that for whatever web-based requirements management tool, you can use this web extension, right? If you want to know more about this web extension, just follow this link in here when you receive a copy of the slides. Just follow this link to know more about the web extension. Where can you reach this extension? How can you install the extension, and so on and so forth. So this is the full ecosystem of tools connected to our repository and our ontology. And we have offered two different flavors of ES patterns. As I was mentioning before, ES is just defining the main blocks, starting with the main keywords, ES keywords, like while, when, if, where keywords, right? So the first implementation of ES is what we call open ES. In the open ES approach, we will just force you to follow the specific keywords and the SAL, and perhaps that's all, right? In order to be a little bit more strict, we have implemented a series of different metrics in order to check things like, well, after the SAL, I don't want to find any ES keyword, or I don't want to find any additional modal verb, or we could force that after the SAL there is at least the name of one entity in our data dictionary. So this kind of metrics are implemented. So this is the open ES. And then the second flavor is the so-called guided ES, which is where we have implemented all these more detailed structures, or what we call in our approach sub-patterns that I was presenting in the previous slides. This has been implemented in the guided ES, right? So this allows the tool to guide the writer of the requirements based also on the information coming from the domain-specific dictionaries to be more thorough guiding the author, right? So the open ES is not connected to the dictionaries, while the guided ES is following the detailed structure, the detailed sub-patterns, and also is connected to the controlled vocabulary in the project data dictionaries, right? So these are the two different flavors that whenever you download our ES library, you will have both possibilities, and you can swap from one to the other whenever you wish. Of course, open ES is more flexible, easier to implement, especially in the first stages of when you start using tools to help you write your first requirements. Perhaps this is the best option, and especially, of course, if you don't have domain-specific dictionaries. While a guided ES is, of course, is more strict, it enables consistent development of both requirements and architecture, and it is, of course, a better option for mature teams and where your domain is mature as well, right? So these are the two options that you have. Each one of them is a nice option depending on the potential scenario where you are. And to complement these patterns with rules, as I was mentioning before, we have implemented a series of different rules or metrics in our tools to be analyzed in real time with the RAP tool, with the requirements offering tool, or in a non-real time environment with either the RQA, Requirements Quality Analyzer, or the Engineering Studio. So this is just an example. We have implemented something like 22 metrics, including, as I said, that the name of the system should be coming from the name of the architectural elements, or just to force that the while condition in complex requirements is always the first keyword. You cannot put the when in front of the while. Also, the while should include at least the name of one entity. There shouldn't be any modal verb in the while block, also to control the length of this while block, and similar restrictions for the other main blocks in the ES pattern, right? So this is what has been implemented in the lab. And now we come to the more practical aspect, where I have prepared two different videos. First one, I focus on the web implementation, the web extension, and I will be using the open approach, open ES. While in the second, I will use a different tool for requirements management, DOS, and I will be more focused on the guided ES. So let's start with the open ES. In this case, I have chosen Code Beamer. So the video is loading. Okay, so now in this video, as I said, I will open Code Beamer. So this is Code Beamer with a document describing the temperature warrior. So I create one new requirement. Of course, Code Beamer, this is a web-based application where I have included the web extension of the authoring tool. Whenever you configure a particular web page to enable the authoring tool, then when you click on the corresponding textual text box, then you will have this green A to represent the authoring tool. So you click on this A, and then you have this gray screen on top of your main screen to write your requirement with the assistance of the authoring tool. So I choose open ears, and then out of the 6 possible requirements, I will start with the more basic ubiquitous requirement. So whenever I choose the ubiquitous requirement, since this is the open ears, there is just a little help from the dictionaries. Of course, you can just see the name of the main nouns and components from the dictionary, but I can write whatever I wish in this first block. Then whenever I have chosen the name of my system, like temperature warrior, then I have the option. Of course, yes, I have another keyword, which is temperature warrior initialization. But in this case, it is just to continue with the shall. And after the shall, the tool will show you a list of potential verbs in the dictionary. But this is not connected to functions yet, just verbs from the dictionary. So I choose my verb, shall include, and the rest is free. So this free typing is represented by this star, this asterisk, but I can write exactly whatever I wish. So something like shall include a control system. So the temperature warrior shall include a control system. So it is kind of describing the architecture. Then I see in these green boxes on the left that this button, the open ubiquitous, is done. So I'm happy with this. I click on the save button, and then I have the text of my requirements. There is no need to copy and paste. Everything is done automatically, and the text of my requirement appears in the text box. So I create another requirement. Same, when I click on the piece of text box to write the requirement, I have the wrap button. I click on it, and then again I choose my preferred pattern to start typing my requirement. So I choose again. I can choose guided or open, but I continue with open, ubiquitous. And then let me provide another example of ubiquitous requirement. So similarly to what happened before, after the temperature warrior, we have the shall, the verb corresponding to the system response. Shall communicate. And now I have freedom to choose whatever I wish. If I communicate with the ground segment, right? So if I finish my requirement here, you will see in a second that the tool will tell you that this requirement is fitting with the structure of an open ubiquitous requirement. So you will see a green box in the left, and you can continue with your happily with your requirement. However, if I continue and I modify this requirement to inject kind of nasty things like, as I was mentioning before, modal verb after the main shall, or these kind of things, then you will see automatically like the tool will complain and will tell me that even if from the structural point of view, it seems that, this is a system response, but the tool is not happy when you use a modal verb after the shall. So this this must after the shall is something that is not expected in our implementation of the years approach, even in the open years. Of course, it is not welcome neither in the guided years. If I use a keyword like while, when, if, after the shall, this is not the good structure neither. So you have another box in the left telling you that while after the shall is not welcome. While should come always in front of the requirement, at the beginning of the requirement, right? So all these are the aspects that are highlighted by the tool. And if you don't like it, then just remove it to keep kind of a nice requirement, and click on the save button to take this requirement into your requirements management. Right now, let me create my last requirement in CodeBeamer. Again, I click on the rat button. And now let me choose guided patterns. In guided, for ubiquitous, we have created three different particular flavors of the ubiquitous requirement. So in this case, I will choose one we have a couple of them, one to represent physical properties, another one to represent the logical decomposition of the system, right? In this case, physical property. So whenever you follow the guided pattern, now the tool is guiding you and it is showing you a list of potential properties first, like the weight, then name of your systems and components. So the weight of in this case, the weight of the temperature variable. So you can choose in the list of all the components coming from the model that you see in front of you. You can choose a given name for your component or system, the temperature variable. And now the rest of this ubiquitous requirement, like shall be, and a specific value for this property. So the weight of the temperature variable shall be 5. After the 5, if I stop for a second, I will see the list of potential properties. So 5 kilo. I could decide to stop here, and this is enough for my ubiquitous pattern. So you saw 1 second ago everything in green on the left. But if I decided to modify this a little bit, yes, tool is telling me that everything is okay. But I can go and add a little bit more information, because saying that the weight should be 5 kilo, that's all, is something difficult to be measured. 5.0000 is something difficult. So it is better if we say something like between 5 and 5.5 or 5 kilo plus minus whatever. So the tool is also guiding you to provide a sort of tolerance, right? So if I include the tolerance, when the tolerance is fully given, 100 grams of tolerance in this case, I will see everything in green on the left. So I could say, okay, I'm happy. So I save, and this is my right. So that's all for the first demo. Now let me go to the second aspect, where we focus even more on guided ears. And now I will show this on top of different tools like IBM doors in this case, right? So this is doors with similar module with requirements for my temperature variable, right? And now here, the way to reach the authoring tool is a little bit different. You have the reach authoring menu on the top, And you also have the contextual menu. So if you go through the contextual menu and insert a new requirement using the authoring tool, then you will find something similar to what I was presenting in the previous. So now the RAT is loading information from the models, the structure of the patterns and information from the models. And I have, again, I have my EOS patterns in front of me, so that I can choose one of the different flavors, the guided in this case, and I choose, well, I have all the potential options here. So let's start with event-driven requirement. As soon as I choose event-driven, I have the when selected. So there is no other way to start an event-driven as to start with the when. So when, now the trigger, when the temperature warrior enters a particular mode, enters combat mode. Now I can choose between having a more complex trigger with and or just add a comma to start with the, let's say, with the system and system response block, right? So let's go directly to the system. So when the temperature warrior enters combat mode, the temperature warrior shall. And now, since we are in this guided, we are guided by the main actions or functions in the ontology or in the model, and shall establish contact with ground station. So the name ground station is coming from as an entity in our ontology. So everything is green on the left. So you can, it means that the structure of this requirement is following the selected pattern. So you just click OK, and you have the your new requirement in those. I create one final requirement. And in this case, I will use what I prefer to call a standard requirement, which is what the ES approach calls complex. I don't like to use the name complex. So it is a full requirement or a standard requirement. So it is forcing you to start with a while. So after the while, I establish my precondition. So while the temperature warrior, in this case, I will establish a particular mode is in one of the potential modes in ready mode. Again, I can use and or to have a more complicated precondition or state, or I can just go to the trigger, starting with the if for unwanted or when for the, let's say, sunny day option. So let's go for the sunny day. So when the sensor detects enemies, and now the system name and system response. Sensor, of course, were coming from the dictionary as one of the components of the temperature warrior. So the temperature warrior shall, now the action from the dictionary or function from the model, in this case it is a transition, so shall enter into combat mode. You see the green frame now on the left. You see this green frame, meaning that the structure is okay, but I can continue with more information, like in less than 1 second or whatever, which is, by the way, optional, right? Or I could even continue with something like in accordance with whatever standard or as per whatever standard. So the tool is guiding you with all the different blocks, optional and not optional blocks of your pattern, right? So whenever you feel ready, if you would like to continue with as per whatever document, then you can do it. If not, you just save and close. Everything is green, so I should be happy with this. So I save and close, and my requirement is there, right? So Once I have finished working with or creating new requirements, I can save doors and close doors, and I can just go into the Engineering Studio. I connect to my database. Now the tool is loading the content from the ontology, the content from the external models connected to this ontology. Now I have here some few documents, so I connect to the same doors module that I have where I have been working with the RAP tool. Now the tool is connecting to doors and retrieving all your requirements from the doors repository. This yellow on the top means that there are modifications in this document. Of course, the modification corresponds to the two requirements that I have added. So I save the content before I just show my final trick, let's say. I go to the quality view. I don't want, as I said, I don't want to focus on this webinar on quality aspects, let's say metric related aspect. But I have completeness metric. Remember our approach CCC for correctness, consistency, and completeness. So I just go and show one metric, which is the completeness metric for patterns. So I have created a metric to check how many of the different patterns I have used in my full specification. So if I open, I see that I am 66% done and 33 is missing, meaning that out of the 6 possible patterns, I have written requirements for 4 of them, these 4, for ubiquitous, state-driven, event-driven, and a standard requirement. But in my spec, there is nothing about optional and nothing about unwanted behavior. So it is now up to you to determine what to do if you have nothing optional and nothing unwanted. And for the second chart, this 80% means that 80% of my requirements are written following the EARS patterns, while still almost 20% are not following EARS structure. So the tool allows you to click on it and see which are in this case, 32 requirements that are not following the structure. So you see at the beginning, well, stupid requirements like the system2 shall function 1, these kind of things. In other cases, we are not meeting the pattern because I am using should, while I was expecting shall, or something is missing, like shall be 150 and the rest is missing, or shall be able to, which is a structure which is not defined in EARS, and of course not welcome to quality standards like the INCOSE, for instance, right? So with this, you can see all the requirements that are not matching, and with one of the structures, for instance, if it starts with a pronoun, it should be whatever. And of course, you could even double click on it and see the details for this requirement and rewrite this requirement with the help of Python, right? So that's all, and this is the end of my webinar. And now we have a Q&A section. Cecilia, if you are there, you can continue with the webinar.
Yes, thank you, Jose. Jose will answer your questions in a minute. So if you have questions for him, please write them down in the questions section. And while you're doing that, I will give you some information about our next webinar. Extended interoperability, connecting tools all over the system lifecycle, even to other organizations. In system theory, interoperability between tools digitalizing the ISO 15288 standard processes is the trigger to support the automatization of the development lifecycle, enabling a complete digital thread. In this webinar, we will see how SES Engineering Studio, following this theory, enables interoperability and sharing of information between peers, tiers, OEM, and even clients. This webinar will be a little bit different. It's organized by the Spanish chapter of INCOSE, and we will send out more information about this soon. The date for the webinar is the 18th of June, and we will have one session in Spanish in the morning and one session in English in the afternoon. So over to the questions. Are the licenses for RAT web browser extension and RAT plugin for doors the same? Is each license specific?
Good question. Yes, they are the same. So whenever you acquire a license of RAT, it could be used on top of desktop applications like PTC Windchill or IBM Doors, and the very same license could be also used in your web browser.
Is the web extension compatible with other browsers? And is there a specific version compatibility?
Nowadays, it is compatible with the Chromium browsers like Chrome, Firefox, and Edge. We are thinking on extending this compatibility with other browsers, but for the moment, only those based on Chrome are suitable for this RAT extension.
Okay. Thank you for the presentation. I saw you had an authoring plugin inside MS Word. Is it also the same license? I suppose this refers to the RAT license.
Yeah, no, it is a different license. In the case of the doors, in the case of the Word plugin, indeed, it is a RAT inside of it is a RAT inside of Word, yes, but it is through the add-in of the Engineering Studio. So in this case, what you need is a license of the Engineering Studio add-in for Word. This is what you need, which is different. So it's similar price, but different license.
Okay. So thank you, Jose, and thank you everybody for attending. If you have any additional questions or want more information about our tools, don't hesitate to contact us by email directly to Jose or to contact@reusecompany.com. You can also find information and videos on our website, reusecompany.com, and on our YouTube channel @The Reuse Company. Thank you very much and goodbye.
Thank you, Cecilia. Goodbye all. See you soon.